Okay, guys, so let's try to understand what is linearity and what is linearity in algebra. And basically, the topic that we are actually wanting to discuss is the linear equations. So, linear equations are basically, for example, I just, write down a simple equation to start with. For example, y is equal to, 2x plus anything like 2x plus 5. So this is an algebraic equation in which we have an output y, which is dependent upon an input x. And whatever the value of x is going to be, it is going to change the value of y. That's why these alphabets are called variables because they're like empty boxes. We have discussed these things in the previous videos that you can just put whatever value into this box, which is, the input box called x, and according to that, the value of y will be, obtained. So let's actually, write down here some arbitrary values of x and some arbitrary, of course, the dependent uh, values of y, the ones that are actually dependent upon x. So for example, I just, give the value of x to be equal to 0, right? And let's see the value of y. What is the value of y if x is 0? Well, if x is 0, then 2 times 0 is 0, and we're only left with this constant value of 5. So y would be equal to, let me do it in different colors. So y would be equal to 5. So let's actually put x to be equal to 1 and see what is the outcome. When x is equal to 1, 2 times 1 is 2, plus 5, that is 7, right? So we can just write down the output value of y, that is equal to 7. And you can just start seeing that whatever the value of y there is going to be a different value for, sorry, whatever the value of x there's going to be a different value for y as an output. So whenever you put, for example, you put the value of x to be equal to 2, 2 times 2 is 4 plus 5, it's 9, right? And you can, just continue making a pattern here like this, and you can just make it as long as you want in order to in order to be satisfied. But this is how it goes: 5, 7, 9, 11, 13, and 15. And we can just confirm it with the last value that we just did. For x to be equal to 5, 5 times 2 would be 10 plus 5, 15. So yeah, y is equal to 15. So what I'm trying to say here is that we increased the value of x linearly. Like, we did not jump all the way, you know, and skipped some numbers. We actually went step by step: 0, 1, 2, 3, 4, 5. And what we observed was the value of y to be increasing. It increased, step by step as well. It increased linearly. From 5 to 7, there's a step of 2. Then 7 to 9, there's a step of 2. 9 to 11, there's a step of 2. 11 to 13, there was a step of 2. And then 13 to 15, there was a step of 2. So it increased in a, arithmetic pattern. It increased in a stepwise pattern. It increased linearly because that's the definition of a line. It always goes straight. Like, for example, this is a line, right? You always draw some points on every step which are equidistant, and then you join together and it becomes a line. However, if, for example, something, or I could just describe this better like this. Let me actually erase this. For example, if you just take one step and then another step, then another step, then another step, and you're just, climbing up this staircase, and once you just start describing your path that you actually travel, it is going to be in a straight line because you just took each step of equal, interval, and you went up the way, like you would in a straight line. However, if you just took steps like this, for example, you took steps like, you took one step and then you skipped a couple of steps, and then you took a giant step like this, and then you took even a giant step, and then you just kept taking uh, bigger and bigger steps like that. In that case, the path that you actually travel won't actually be like a straight line. It would rather be like a curve because you're going exponential. You're going higher and higher every step. So something like that would be called as a non-linear pathway, but something that has equal steps would be called as a linear pathway. An example of the nonlinear pathway would be an equation like y is equal to, for example, x square. Whenever you put the value of, you can just try it out here. Whenever you have the value for x to be equal to 0, you will have the value for y equals to 0. But as you just start observing this, when you put the value for x to be equal to 1, the value of y is going to be 1 square, which is 1. So far looks fine. But when you just put the value for x equal to 2, you would observe the x squared, that means 2 squared, which is equal to 4. So value of y is going to be 4, and so on. 3 square is 9, 4 square is 16, 5 square is 25. So you can observe that you kept increasing the values of x step by step in a linear pattern, 0, 1, 2, 3, 4, 5. However, the result, the output value of y did not increase stepwise. It increased like this: 0, 1, 4, 9, 16, 25. It kept increasing with every single step that you took. So it is more like a curve which is non-linear. It is not going in a straight line. So we call that type of thing to be non-linear. However, if the output steps are equal, like we found out in the previous case, the first case, this one, in that case, you would call something like that, a pathway like that, to be as a linear pathway, right? So the general idea you get from linearity is that whenever you have an algebraic equation in which you have this, input value of x on which the output value of y is dependent upon, if the exponent of that, or the power of that, input value or variable is 1, then you will have a linear equation, linear algebraic equation. However, if you just have an exponential value, the exponent is greater than 1, if you have power that is greater than 1, like 2, 3, or any number greater than that, in that case you won't be actually having a linear uh, result. You will be having a nonlinear result, more like a curved result, as I explained, by giving this example over here of a staircase. So the general idea you get of linearity is by visualizing an example like that. So I hope you get an idea what I'm trying to say.